Hello everyone, welcome back to PMAC1105. In this video, I will be talking about section 7.2, and 7.2 is about a system of a linear equation in 3 variables. But in order to understand this concept, I just want to do a quick recall on the system of 2 variables first. Okay, so let's get started. Section 7.2 system of linear equation in 3 variables. Okay. Okay, but so first of all, let's do a quick recall. Okay, recall because it's in order to understand this system in 3 variables, we need to understand system of 2 variables, and we already learned in the system of 2 variables in intermediate algebra, and the solution of system of 2 variables is nothing but intersection point of 2 lines. Okay, and if we have infinitely many solutions, it means the 2 lines overlapping each other. If we have 2 lines parallel to each other, then we don't have any solution. And the standard form of system of linear equation in 2 variables will be something like this. Right? Hopefully you guys still remember ax plus by equals c, right? a1 plus b1 b1y equal to c1, and if we combine with another linear equation in standard form is a2x plus b2y equal c2. We combine these two, then we have a system of linear equation in 3 variables. Okay, and if we have a consistent system, then we have the solution. If we have inconsistent solution, then we don't have solution. So that is the concept we learn in intermediate algebra. And intermediate algebra, we also have when we solve system of linear equation in 2 variables, we also have 2 methods, right? Substitution method and elimination method. Let's see for the system of linear equation in 3 variables, are we going to use the same strategy? Are we going to do this substitution method and or elimination method, or we just can use only one? Okay, so let's jump to our concept today. I'm going to write a little bit more here. The solution of the above system is intersection point of 2 lines. Okay, 2 lines. I'm going to put over here L1, and the line over here is L2. 2 lines L1 and L2. Okay, L1 and L2. Right. Now let's jump to our concept today. System of linear equation in 3 variables. Okay, so we can extend the concept by adding another variable and adding another equation into the system. So instead of having a1 b1 only, we're gonna have c1 over here, and over here we're gonna have d1. So we'll have something like this. a1x plus b1y plus c1z, okay, equal d1. Okay, so we have, you see, we have three variables x, y, and z, and we combine with a2x plus b2y plus c2z equal d2, and we have a3x plus b3y plus c3z equal d3. Alright, so what I have to over here is standard form of the system of linear equation in three variables x, y, and z. So the solution of the system here in three variables is because over here we have three variables, it's not a line anymore, but instead it's a plane. Okay, it's a plane. It's a plane P1, P2, and P3. So the solution is what? The solution is nothing but the intersection part. Okay, the solution is intersection part amongst the plane P1, P2, and P3. So this is the intersection part. So what the part that look like? If we have three planes, just imagine I have three planes like this. Okay, let me draw a plane. Geometrically, this is a solution of the system of linear equation in three variables. It's something like this. I have a plane, right? I have a plane. So a plane is like a surface. Just you can understand it like that. So and this plane is P1, right? And I have another plane, and this plane is perpendicular. This is perpendicular to P1 at the line here. Okay, so this is perpendicular. So something like this. There you go. So this is P2. Okay, and other than this, I also have another plane. Okay, another plane. Oh, it's kind of hard to draw. Let me see. I can draw that. Let me erase this. So this is intersection. So I have another plane. Okay, and it look like this. Let me see how I'm gonna draw it. So I have another plane. It's kind of go through this. Let me erase this a little bit more. Let me erase this too. Okay. All right. So I have another plane that look like this. So this kind of okay, and like this, and it's going through this. Okay. There you go. I don't know. You can imagine that. So this P3. So you see that three plane, three surface. You can understand like that. Intersecting each other, and the part where they're intersecting each other will be this part. Will be this part right here. All right. So the intersection part, the solution is actually it must contain 3 points. Okay, because intersection part right here is a line. It's a line. Okay, this is a line right here. That's the solution. And if three plane parallel to each other, and you see that we don't have any solution because there's parallel to each other. So P1 here and P2 here and P3 here, and it's parallel to each other, so there's no solution. Okay, so that is the case when the system doesn't have any solution, and if they have a solution, we call that consistent. Okay, and over here we call it inconsistent. Okay, so if there's another case where we have three plane overlapping each other. So P1, P2, P3 is kind of overlapping each other. So I have another plane is overlapping each other. So this is in green, white, and the other one is in purple. So three plane overlapping each other. Then we also have a solution, but in this case we will have many infinitely many solution. Okay, we have a bunch of solution because there's so many points. They share in common. Over here we have a whole line. We have points over here. Okay, we have the line in common, but over here there's a line. So, and over here we have infinitely many points in common. Because every time we talk about plane, we talk about the geometry shape in 3D, in three-dimensional system X, Y, Z. You know, so if we draw a system, it's not just X, Y, but this is Y over here, and this is Z here, and X here, and Y here. And that's why we have X, Y, Z. Okay. Okay. So now on this next, I'm going to give you an example, and let's see that we can solve the system by either method, substitution or elimination or not. Okay. Yes, in reality, that we can solve the system with two methods, substitution and elimination method. The same thing as we solve for system of linear equation in two variables. And again, some method is better and a faster way to solve than the other method. So it's up to you. Okay, it's up to you what if you want to use which one. Sometimes you prefer the substitution. Sometimes you think the elimination is better. So it depends on the problem also. Okay. Okay. So let's start with our first example. Okay. Okay. So okay. So let me give you something like this. Okay, example number 1. Okay. Let's see. We can use substitution or elimination. Which one is better? So I have the system like this, and I want you to solve 3x plus 9y plus 6z equal 3, 2x plus y minus z equal 2, and the other one is x plus y plus z equal to, also equal to. Okay. Alright, let's see. Answer. Alright, let's see, we do substitution or elimination here. So look like over here we have plus and minus already. If we add these two equations, this is the first equation, 1, 2. This third equation. If we add these two here, 2 and 3, then look like we can eliminate the z. Okay, we can do so. Okay, then let me see. Then we can solve, or we can solve y in term of x. Okay, then we plug over here. So look like in this one we can eliminate first, then substitute later. We can do both method at the same time. Or if you do substitution, you're going to solve x in terms of yz. Okay, and you're going to plug here, and you're going to plug here. So x in terms of you're going to plug over here, right? So then you get y in terms of z, then you get plug. So z in term, and then you plug over here. So this you have to be the problem of solving system of linear equation in three variable is that you have to be more flexible. You have to see. Sometimes you have to do both way, you know, to see which one is the best way. So first of all, because I see over here plus and minus, I just go ahead apply the elimination method first, in which is I just eliminate the z over here. So I'm gonna add 2 to 3. Okay, the second equation to the third equation. I'm gonna have 3x plus 2y equal 4. Okay, all right. Then what we do? So we can then we're gonna solve x in term of y. Then we're gonna plug over here. Maybe. What do you think? Or we can multiply over here by 6. Then we're gonna eliminate. You see that? We multiply the second equation by 6, right? Then we eliminate the z. Then we have another equation, right? X in terms of x and y. So just think about it. I multiplying second equation by 6. Then what we're gonna have? We're gonna have 12x, right? 12x plus 6y minus 6z equal 12. Okay. Then if we combine this with the first equation and we add these two up, okay, add this to this, okay. So add this to this, we're gonna give you so that we can eliminate the z. Then they give you what? 15x, right? Plus 15y equal 15. And if we simplify this, we give x plus y equal 1. Now I'm gonna combine this one and this one. So I call this I'm gonna call this equation star, and I call this equation double star. So I combine this star and double star. Then we're gonna have what? We're gonna have the system in 2 variable. So originally we have the system in 3 variable. Now we have a system in 2 variable, right? And we have a system in 2 variable. We can solve it by substitution or elimination. So let's see. I can solve it by substitution. So I solve y in terms of x, 1 minus x, right? Then I'm going to plug over here, then the equation becomes 3x plus 2, 1 minus x equal 4. Then I have 3x plus 2 minus 2x equal 4. Then x equal 2. Is that x equal 2? Yeah. 3x minus x, 4 minus 2 is 2. So x equal 2. Then your y will be equal 1 minus 2 is equal to negative 1, right? Y equal negative 1. And from there, I can solve z. So I'm going to plug into the third equation here. So x equal 2, y equal negative 1. plus z equal to, then plus minus minus 2 minus 1 is 1, 1 plus z equal 2, z equal 1. There you go. Then I have z, I have x, and I have y. Right? Alright, so what we learned from the first example here. So we learned that the difference every time we solve system of linear equation and system of linear equation in 3 variable and 2 variable is that for substitution and for system of linear equation in 2 variable, you can apply either substitution or elimination. But when you solve a system of linear equation in 3 variable, you have to be more flexible. It means that you probably have to apply both substitution and elimination. It depends on the problem. Sometimes, so you see it over here. I do elimination to get rid of the z. Then over here I do substitution. Okay, so there is no strict strategy of solving system of linear equation in 3 variable. You have to be more flexible. As long as you simplify the system in 3 variable into something easier for you to do, okay, then you can get the answer. This you don't have to follow a unique method, like you have to do the substitution or you have to do elimination. You can use anything you want, okay, and you can combine both strategy in order to solve system of linear equation in 3 variable. Okay. Now let me give you another example. Let's see. Let's see what happening in the next example here. Let's see we can be more flexible or not. Okay. So, example number 2 here. So I have a system like this. I have x plus 2y plus z equal 4 and 3x minus y minus 4z equal -9. Okay. So I have just have the system like this, and even though that you see the equation, we don't have the third equation, right? But it's still a system of equation in 3 variable, because I mean actually the third equation is just they don't have it. It doesn't have it, but we still have variables, so it's still consider a system of the equation in 3 variable. Okay, so how we gonna do in this case? Actually, the third equation is kind of invisible. You're gonna be it's gonna be 0x minus plus 0y plus 0z equals 0. So that's the third equation right there. So every time you see something like this, you see that. Okay, you see this. So over here we can eliminate. So this is equation 1, equation 2. If I multiply equation 1 by 2, then we have what? We will have the system like this, right? By 2, so be 2x plus 4y plus 2z equal 8, right? And 3, oh, multiplied by 3, I'm sorry, it's by 3. Actually, 3, 6, 3, 12. So with 3x minus y minus 4z equal -9. So they have system like this, and we subtract the first one by the second one, right? So what we have 3x minus 3 is 0, right? Then minus will be 7y, right? Plus 7z equal 7. So you have y plus z equal 7. Okay, you have y plus z equals 7. Then from here, then you can solve for z equal from this is 7 minus y, right? Z is 7 minus y. And if you plug into one of this, so you can solve for x, right? So x equal to 2 y. C is 7 minus y, so 7 minus y here, right? Equal 4, right? Then you have x plus 2y plus 7 minus y equal 4. Then you have what? X plus 7 plus y equal 4. Then x plus y equal negative 3. Then from here I can solve x in terms of negative 3 minus y. So what we learn from here? What we learn is that z will equal to 7 minus y, and x is also equal to negative 3 minus y. So I can get the z as long as I can get the y, right? And x as long as I can get it. So one y I can get one x and one z. Okay? So if you have two y, then any y, you can have any y, right? If you replace y with any number, then you can get z and x. Alright. For example, if you replace y with 1, then you can solve for z here. You replace y with 1, you can solve for x here. So with one y, I can get x and z at the same time. Okay, so what we can conclude over here? So we can conclude that no matter what y, we can get x and z. Right? So it means that we have infinitely many solutions for this system. Well, originally, if you look at the question, it should be, because I just told you that this is 0x plus 0y. This is 0x plus 0y plus 0z equals 0. I mean, everything over here is 0 equal to 0. This is fact. This is true. As if it's something, remember when you solve system of linear equation into variable, when you have something true, then you can jump into conclusion is you have infinitely many solution. But for the system of 3 variable, you have to. This is the work you have to solve. You gotta write x. You can solve x and z in term of one variable, or you can solve y and z in term of x, or you can solve x and z in term of y, or you can solve x and y in term of z. In that case, you show that the system has infinitely many solutions. Okay, all right. Of course, you see, this is going to be more complicated in the system of 2 variables, but it's not really that bad, because the step is kind of the same. It's always the same. Okay. All right. Let me give you something like this. Example 3. Let's see what happened here. X plus 2y equal plus z equal 39. X plus y plus 3z equal 37. And 2x plus 3y plus 4z equals 77. Alright. So again, when you solve a system of linear equation into a variable, you have to be more flexible. You try to get rid of the variable so that it give you the system of 2 variables, and you can solve it from there. You know, that's just the strategy. That's the general strategy. You try to bring it from the system of linear equation in 3 variable to the system of linear equation in 2 variable. Then you can solve. Okay, and sometimes you can eliminate everything right at the beginning, get x, y, z. And sometimes you can do substitution. Sometimes you can do both at the same time. So you have to be more flexible. Okay, that's the only general strategy, is that you try to bring it to the system of linear equation in 2 variables so that you can solve. Okay, but other than that, there's no specific method for system of linear equation into a variable. You can apply anything you want as long as you can get x, y, z. Okay. All right. So let's solve this. Answer. Okay. So if you recognize, you see over here the x and the x, it's the same, right? X and the x are the same. And if I multiply the second equation, okay, so this is the first one, the second one, the third. If I multiply this second equation by 2, then if I subtract by each other, so probably we can get rid of the x2. So over here we can get rid of the x already by doing the subtraction. So you see that in the first system of linear equation into variable, most of the time we add, right? Actually, we can subtract 2. As long as you can get rid of it. So I take 1 minus 2, so you have 2 1 minus 1, which is y, give you negative 2z equal 39 minus 37 give you 2. And if I just go ahead multiply the second equation by 2, okay, multiplying a second equation by 2, then what we would have? Multiply second equation by 2, so I have 2x plus 2y plus 6z equal to 74, right? And I combine this new equation over here with the third equation, which is the 2x plus 3y plus 4z equals 77, and I go ahead and subtract these two equations together. So let me call this equation is the 2 prime, and over here is the second 3 prime. So this is just the name, okay? Then I take the second prime equation minus the third prime equation. Then what we have 2x minus 2x 0, 2y minus 3y is negative y. This gives you 2z, right? So the 4 minus 77 gives you negative 3. And now what? Originally we have system of 3 variables. Now I just go ahead and I have the system of equation into in 2 variables, not 3 anymore. You see that? This one and this one. So now I can go ahead and combine this one, the one I just have it here, and the new one, right? Okay. And now you see that the y variable here, I'm sorry with my allergy, you see the y variable here is in opposite side, right? Now I just go ahead and add them up together. If I go ahead and add them up, so these two equations add up, y plus negative is 0, so the 0 here. So if I go ahead and add them up, so what they give you? 0, right? Equal negative 1. Okay, so what do you have over here? 0 equal negative 1? Something doesn't make sense, right? So this is not true. It's not true. So if you simplify a system of linear equation into in 3 variables, and you have something that is not true, then you can jump to the final conclusion that this system has no solution. Okay, no solution. If you have something that is fact, this is true all the time, no matter what. For example, 1 equal 1, 2 equal 2, 3 equal 3. Then that system has infinitely many solutions. But if you have something that is not true, then the system has no solution. Okay. All right. Now let me give you another example. I'm trying to give you something that has solution this time. Let me see. How about this? Kind of interesting problem right here. Okay. So I have a system like this. I have 3 over x, okay, plus 2 over y minus 1 over z equal 11 over 6. second system is 1 over x minus 1 over y plus 3 over z equal negative 11 over 12. Excuse me. And the third one is 2 over x plus 1 over y. Again, I'm sorry for my allergies. I have pretty bad allergy. It's not gone. It's chronic allergy. Sometimes it's go and it come back. Okay. All right. So I have a system like this, and you look at this and you see, oh, this is more complicated than the first three equations, right? Because it has fraction and x, y, and z is in the denominator. But again, it's just a system of three variables, so you're going to do the same thing. Okay, you're going to try to get rid of so that you have a system of two variables. So what we have over here, if you just go ahead, you see that if you go ahead and you multiply over here by 3, you multiply here by 2, then you can get rid of this and this, right? This is the first one, second one, and the third one. So I multiply the second equation by 2, okay? I multiply this second equation by 2, both sides. So I will have what? I have 2 over x minus 2 over y plus 6 over z equal negative 22 over 12. Okay, and then I'm gonna just go ahead group them with the third equation, 2x plus 1 over y plus 1 over z equals 7 over 12. Alright, so from these two here, I'm going to go ahead and do subtraction by each other. So 2x minus 2x minus 2x. This minus this will give you negative 3 over y, right? Plus 5 over z equal negative 29, right? Because negative 27 minus 7 is 12. Okay, and you do the same thing for the second equation, but instead of multiply by 2, I multiply it by 3. So I'm going to group with the first one. So I have the first one is 3 over x plus 2 over y minus 1 over z, okay, equal 11 over 6, and I multiply it by 3, so I have 3 over x minus 3 over y. Multiply this one by 3, okay, plus 9 over z equal negative 33 over 12. Alright, now we're going to go ahead and subtract each other. So I have this minus gone, right? Minus will be 5 over y minus 10 over z, right? This minus this will give you negative 44 over 12. Okay, now what we have here? Well, originally we have 3 variables. Now we just simplified into 2 variables. Okay, now we're going to go ahead and combine this into a system of 2 variables. So let me jump to the next page here. So we have negative 3 over y plus 5 over z. Okay, negative 3 over y plus 5 over z, right? Plus 5 over z equal negative 29 over 12. Negative 29 over 12. And 5 over y minus 10 over z. 5 over y minus 10 over z equal what? Equal, oops, equal 44 over 12. Okay, 44 over 12. Alright, so I have the system now. Okay, so what we see over here. Okay, before I continue, I just want to go back and check if there's something wrong, because this fraction over here doesn't give me a good feeling at all. So let me go back and check. I think I had some kind of mistake here. Let me see if I add a multiplied by if I go ahead and subtract, so 11 over 6. I think something wrong right here. So this is multiply, so add subtract, right? So 11 over 6 11 over 6. Oh, I don't know why what's wrong with this. Oh, I'm sorry. 11 over 6 minus 33 over 12. I see there's something wrong right here. So give you 11 over 6 plus 33 over 12, which is 44. No, multiplied by 2, right? So it's 22. So 22 over 12 plus 33 over 12, which is 55 over 12. Okay, 55 over 12. It's not a nice number either, so I have to change it. So over here, let me rewrite the whole system. So I have here. Let me see if the system is right or not. So it's 55. Right, it's 55 over 12. So over here will be 55 over 12. Okay, 55 over 12. And now I'm multiply over here by 2 again. So which is give you what? Which is give you negative 6 over y plus 10 over z equal 58 over 12. Hopefully that give you a nice number, because the fraction doesn't give me a good feeling at all. Alright, now we're gonna just go ahead and I'll give you negative 1 over y equal negative 3 over 12. So your y should be okay, so this is give you 3y over 12 and y equal 4. Oh, this nice number right here. Okay. Alright, so y equal 4, and you're gonna plug over here in order to get z. So you have 5 over 4 minus 10 over z equal 55 over 12. So you have negative 10 over z equal 55 over 12 minus 5 over 4. So you multiply by 3, so you have 55 over 12 minus 15 over 12, which is 40 over 12. Right, and so let me see this is correct or not. 5 over 4. Okay, 3 over here, 3, 15. 40 over 12. Okay, so you have z will be so z will be negative 120 z equal to 40, right? No, 120 negative 1 multiplied by equal to 40z, so 40z equal to negative 120. So your z should be negative 3. Oh, that's a nice number. Okay, so that is your z. And then you can plug into the original equation to find x. So you have the original equation is 1 over x minus 1 over y plus 3 over z equal to negative 11 over 12. So you have x is, you want to find x, right? So y is 1 over 4. Z is 3 over negative 3 equal negative 11 over 12. So 1 over x minus 1 over 4 minus 1 equal negative 11 over 12. 1 over x. This is give you negative 5 over 4 equal to negative 11 over 12. So 1 over x equal to negative 11 over 12 plus 5 over 4. So multiply by 3 over negative 11 over 12 plus 15 over 12, which is 4 over 12. So so 4x equal to 12, so x will be equal to 3. Okay, so x equal to 3. Here you go, this time it's nice number. So you have x equal 3, y equal negative 4, and z equal 3. Oh, 5 plus 4 and z equal negative 3. That's your final answer. Does this make more sense? Okay, right? Because if I see that if you feel that there's something wrong, you better go back and check, because the fraction is killing us, right? Okay. All right. Let me see. I'm gonna give you another one. Look like all the problems kind of the same. You have the same strategy. So the strategy, the general strategy is this. The general strategy is general approach. Okay. We can conclude out of these 4, 5 examples here is that eliminate one of the variable, okay, to bring 3 variable system to 2 variable system. There you go. That's the general strategy. Okay. Alright, so I think I'm gonna stop our lecture right over here. Again, in order to be good at it, you have to practice a lot. But this is basically just elimination, substitution. Look like I do a lot of elimination here, but yes, you can do substitution. Substitution, it takes more time, okay? But some students prefer substitution, so I don't mind. So I just on the test I said, solve the system. You just go ahead and solve by any method you want to. Alright, I'm gonna stop here, and I'll be seeing you next time in the next video. Bye bye.